Good day! So welcome to this video. Ang next topic natin ay yung continuation ng discussion on the fundamental theorem of the calculus. So today we'll look at the second part of the fundamental theorem of the calculus. And ito yung theorem as stated. So kung meron daw tayong function na continuous on a closed interval a to b, then the definite integral from a to b of this function will be equal to capital F of b minus capital F of a. Pero ano ba si capital F? Capital F is any derivative of the function in question, si lowercase f of x. And before we proceed, let's recall kung ano yung sinasabi sa atin ng first part ng fundamental theorem of the calculus. Ang sabi niya, if we take the derivative of a function na ang pagkakasetup ng function ay the definite integral from a constant to x of f of x, makukuha ulit natin si f of x. Ang ibig sabihin nun is if we will construct a function na ang definition ay the definite integral from a constant to x of f of x, ang makukuha nating result ay antiderivative nung function na nasa loob nung lowercase f of x. So let's proceed. So let's just keep yung statement dyan para madali nating makita kung saan tayo pupunta, kung ano yung objective natin. So let me first draw two Cartesian planes. On the left, I will draw a function f of t. Ang gusto kong gawin ay gumawa ng definite integral from c equals 0 to x. So hindi ko muna gagamitin yung a and b kasi gagamitin natin siya mamaya. So I'll just use a different variable. I'll use c, let this be equal to 0. And we'll look kung ano yung magagawa natin if we take the definite integral from 0 to x of f of t dt. So I'm using t as my variable instead of x kasi yung x, nilalagay natin siya as the upper limit of integration. From the first part of the fundamental theorem of the calculus, this will generate a function, capital F of x. I'll call it muna capital F sub 1 of x kasi we could generate many such functions na yung capital F sub 1 of x na yan, isa siyang antiderivative ni lowercase f of x. But right now, it's f of t kasi we're using t as our variable. Paano ulit yun? Let's define yung starting point natin, yung lower limit, yung c equals 0. And let's put x at its leftmost part. So I will have here the definite integral from 0 to x. But notice that we are moving from right to left. So mas maliit yung value ng x dun sa 0, negative si x. So in that case, yung region above the x-axis, negative siya kasi right to left natin siya ine-evaluate And the region below the x-axis will be positive kasi kahit negative yung negative siya as a definite integral, dahil in-evaluate natin siya from right to left, then mag-negate na naman siya. So naging positive na siya. So what we'll do dun sa Cartesian plane sa right side is we will plot yung value nung definite integral kung nandito yung x. So right now, it's about 0. So as we move our x, from left to right, magiging mas negative yung value nung points nung function natin na ginagraph dito sa Cartesian plane sa right side. Kasi ang natira na lang na region ay yung negative. Again, it's above the x-axis but it's evaluated from right to left. So yung value, yung definite integral from 0 to x, negative na siya. Now, observe as we will move from left to right yung x natin, so igagalaw natin yung x natin dun sa function sa kaliwa, tas ipa-plot natin sa kanan yung value ng definite integral, well, lalapit siya sa 0, di ba? Yung x. So, mauubos yung negative value na yan. So, we expect that will be approaching 0. Now at this point, I'll just have to recognize some of the limitations of the program I'm using. This is Manim. For some reason, pag nag-animate ako ng functions, hindi niya nare-retain ng maayos yung mga previous points na nakaplot. Gumagalaw-galaw sila. Parang fino-force niyang i-animate and hindi na siya ganun ka-accurate. But we'll just wait until matapos yung animation to get a more accurate picture of the function. I tried fixing it. I couldn't find any references sa internet kung paano siya i-fix. So medyo weird yung magiging behavior nitong function sa kanan. But it more or less approximates yung values nung definite integral from 0 to x na nandun sa function sa kaliwa. So let's continue. I'll keep on moving the x value So as it approaches 0, yung value din nung definite integral niya will be approaching 0. So again, itong nasa right side, siya yung actual value ng definite integral. Then now as we move from left to right, yung x natin, andun na tayo sa positive na definite integral. So tumaas na siya. But then magkakaroon tayo ng region below the x-axis. So may downward behavior yung graph natin sa right side kasi it's graphing kung ano man yung value ng definite integral eh. And then as we go up, no, as we continue moving our x to the right, edi magiging positive na siya. Then magkakaroon na ng upward swing yung function dun sa right side. So the first fundamental theorem of the calculus states that itong nasa kanan na function, antiderivative siya nung nasa kaliwa. And let's call this function on the right side capital F sub 1 of x. So why am I using capital F sub 1 of x? Well, tignan natin yung mangyayari pag nilipat ko yung lower limit nung definite integral natin sa definition ng function. So instead na c equals 0, ilagay natin siya sa c equals negative 1. So now, the starting point will be here sa c equals negative 1, and at c equals negative 1, the function lowercase f of t will be equal to 0. So when we start moving our x value, this will be a positive, no? Kasi nasa yung definite integral natin positive kahit below siya the x-axis kasi nga it's evaluated from right to left. Then as we move closer sa negative 1, tatama ng 0 yung value ng function natin. Then as we proceed moving to the right, no? Yung values ng definite integral na pinaplot natin sa right side, edi positive na siya. Then bababa lang siyang konti, then it will go up. So notice that they have the same shape. Yung dalawang functions na to, yung kulay blue, which we will now call f sub 2 of x, capital F sub 2 of x, it's precisely the same shape, no, nung capital F sub 1 of x. They only differ by a constant. So ito yung parang manifestation ng plus c. Kung saan mo ililipat yung starting point natin na lower limit, here in this case yung lowercase c equals negative 1, ang result, no, nung pagplot nung values ng definite integral from the lower limit to x will just be the same pero nagde-differ lang sila by a constant. Kasi if you take the derivatives of capital F sub 2 of x or capital F sub 1 of x, you will still get yung lowercase f of t or lowercase f of x. Kasi hindi naman nagmamatter yung constant sa differentiation, 'di ba? It will just end up na 0. So, regardless kung ano yung starting point natin, yung lower limit natin, pag in-evaluate natin yung definite integral from c to x, from some constant to x, we'll get the same function na nag-differ lang by a constant, which is consistent with our understanding of antiderivatives. So now, ang kailangan nating tandaan, no, yung mga functions na nakagraph sa kanan na Cartesian plane, these are antiderivatives of lowercase f of x. So for the purposes of our discussion nitong second part of the fundamental theorem of calculus, let's just use one. Si capital F sub 2 of x na lang. We should note, no, that it doesn't matter kung ginamit natin si capital F sub 2 of x or si capital F sub 1 of x or any other capital F of x na nag-iba yung starting point nung lowercase limit. We'll just use any of those. Kaya natin pinili si capital F sub 2 of x. So ano ulit si capital F sub 2 of x? This is the definite integral from negative 1 to x of f of t dt, lowercase f of t dt. And what we're interested in is what is f sub 2 of b. So here, pinlot ko muna, no, dun sa function sa left, yung locations ni point A at point B. And ang objective natin ay mahanap yung value nung definite integral from A to B ni lowercase f. So yung area nung region na bounded by lowercase f, x equals A, x equals B, and the x-axis dun sa kaliwang portion ng graph. So hindi na natin masyado titignan yung nasa right side, no? Ginamit lang natin siya to establish na function yung antiderivative or madaming function yung antiderivative. So nasan si definite integral from negative 1 to b, which is capital F sub 2 of b. This is the definite integral from negative 1 to b, itong region na shinade natin ngayon. Now let's take a look. Pinlot ko lang siya sa right side kung nasan siya dun sa graph natin. Yung value nung definite integral nung region na yon as plotted on a Cartesian plane. Yung y value is equivalent to the definite integral. Now, let's take a look at f sub 2 of a, the definite integral from negative 1 to a. Oops, nagsimula na siya mag-shade. So, actually, ito yon, no? Yung kulay red. And dun sa function natin sa sa kanan, that should have been a. I think I mislabeled it sa b. Dapat a siya. But that red region, or pink or orange, whatever region, is f sub 2 of a, or the definite integral from negative 1 to a of f of t dt. Now, let's take a look at our theorem. We want the definite integral from a to b, not from negative 1 to b, and not from negative 1 to a. But what can we do? The definite integral from a to b is just, tatanggalin natin yung region from negative 1 to a from the region ng negative 1 to b. So, we're just subtracting the definite integrals. So now, here, definite integral from a to b is equal to the definite integral from negative 1 to b minus the definite integral from negative 1 to a. And yun na yung region na gusto natin makuha. Pero balikan natin yung discussion. Ano nga ba yung definite integral from negative 1 to b? At ano yung definite integral from negative 1 to a? Those are f sub 2 of b and f sub 2 of a respectively. So, ano nangyari? Anong binibigay ngayon nito sa atin? Ang sinasabi niya na kung gusto natin kunin ang definite integral from a to b ng isang function na f of t dt or f of x, papalitan lang natin yung variable, hindi na natin kailangang i-evaluate yung limit ng Riemann sum. So, kailangan pa rin nating alam natin yun kasi dun nang galing yung concept na to. All we have to do is to find a single antiderivative of f of x. And i-evaluate natin yung antiderivative na yun at b, yung upper limit. I-evaluate natin siya at a, the lower limit, and we'll take their difference. And that will give us the definite integral from a to b of a function without having to evaluate the limit of the Riemann sum. So what we'll do after this video is to take a look at some examples para ma-appreciate natin kung kaano ka-powerful na shortcut itong binigay sa atin nitong second part ng Fundamental Theorem of the Calculus. Although syempre naka-build siya dun sa first part. So I hope that this is made more clear when we take a look at several examples, and I'll see you sa next videos. Salamat sa pakikinig.